Welcome back to class. This topic for today's lecture is HVAC Basic Systems Coordination. And before we jump into coordination issues, we're just going to spend a little bit of time going back over what forced air systems, basic stuff. So a furnace and the cooling section of a furnace or a forced air system. So let's go pick up where we left off with the refrigeration system and the evaporator condenser. So you're looking here and it's labeled, but we've got the evaporator coil, the blower, and those are here, right? So we've got the evaporator, the blower. So here's our forced air system here. It's not showing the heating section in here for some reason in this graphic, but whatever, it doesn't matter, right? We all know that there's like a furnace, and on top of the furnace, the evaporator or cooling section sits. So we've got our evaporator coil here, and we've got our condenser compressor or our condensing unit outside. Notice the outside wall. And what are these? These are the refrigerant lines, right? So let's look closely at the cycle again, and we'll come back to this. So the cycle start. We'll just start it with. Let's start at the compressor. The compressor's getting refrigerant gas, and it's at a temperature of 68 degrees or 52 degrees Fahrenheit, and it's low pressure over here. The compressor. Let's go back to the slide. Compressor's outside the house. Sorry, between the two graphics, one shows it on the right, the other one shows it on the left, but basically we've got a line dividing here saying high and low, so kind of like in between these two, but let's go back to it. So we've got the refrigerant gas. This is outside in the condensing unit. The compressor is compressing the refrigerant gas. The refrigerant gas is turning into a liquid because it is being cooled off, and it's under high pressure, so it's hot. It's going to turn into, in this case, 160 degrees. As it starts to condense and cool off, it's coming back and turning into a liquid at 95 degrees. The reality is, like, this graphic is a little bit off, right? So the graphic should really start with gas up at the top, wham wham, like this, and it should have liquid coming out the bottom because that's how the condensing coil is. But this is a schematic in nature, so it doesn't matter. But if this was really drawn more accurately, I think that it would be more accurate to show the gas coming in the top and it condensing and turning liquid and going back over here. So same thing with this. I think the whole thing would be better upside down, but whatever, because the liquid's usually in the bottom of the coil, not the top of the coil. Anyway, the point being, it doesn't matter. And so we've got our condenser cooling off the gas, the high pressure gas getting cooled off, turning into a liquid, refrigerant liquid. It hitting an expansion device. The refrigerant hits this expansion device, changes the pressure back to low pressure. This refrigerant begins to go under low pressure, so it's going to start to boil. In order for it to turn from a liquid to a gas and turn into a vapor again, it needs to gobble up as much heat as it possibly can. So it takes air that's being blown across its coil, and it steals heat from it in order for it to make its phase change back into a liquid. And we are now, back into a gas, and that's the evaporator section, right? So we're seeing that happen here, where so high pressure gas coming like this, turning into a liquid, being condensed, liquid, hits this, it's not shown, but whoops, it hits this expansion device, somewhere down here, and it wants to turn into, it starts to boil, and this line should probably be up here somewhere, but it doesn't matter because this is still schematic in nature. And so this coil right here, the refrigerant is cooling off the air because it's trying to change from liquid to a gas, and it lost some of its heat here, and so it's cooler as it goes back into a gas form and back into the compressor to be compressed again into high pressure gas, high pressure liquid, cooled off a little bit more, coming back in here, allowing it to be changing pressure again with the expansion device, and the expansion device allowing it to turn from a liquid to a gas, steals all the heat from the air, and cycle starts all over. So that's what's going on that guy. Hopefully that made sense. And I think most folks, from what I saw on the quiz, understood it okay. Not great, but that's okay. You're not supposed to be a refrigerant expert at this point in time, but I do want you to have the concept. Now, we talked about this already a while ago. So we've got this is the furnace, and we've got a heat exchange going on here. And this one's showing like a natural gas. We've got the burner here, got our clamshell right here. The blower's blowing air across this clamshell. The blower for the furnace is the combusted gas is inside these little metal things right here, these metal clamshell area, and air passing over it absorbs all that heat and goes out to the house, right? So that's the furnace. Now on the commercial side, I'm not going to spend a lot of time. I think people got that one. On the commercial side, and even on like some multifamily, you've got the idea of a rooftop unit or a packaged unit. So packaged unit are the furnace and yeah, on this one, I don't think it's showing the furnace. Yeah, it's mostly showing on this graphic right here. Let's see if the next one's got it. Yeah, this one's better. I mean, so we got packaged unit, and they're calling this a combination unit. So we've got the blower, we've got a cooling section over here, and the heating section over here with the blower. And so the point being, all of it's self-contained in one piece. It's all outside. It's all sitting on top of the roof, sort of looking like that. But this is a very big version of the unit, the combination unit. And so this is a really big version of this, even though I think these can still be pretty small. So we've got this idea where in the residential side, on a typical residence, we've got the condensing unit outside and the furnace with the cooling section inside. On a commercial building, you could have that entire setup all packaged into one unit, combo unit, or packaged into what they're calling a packaged unit, packaged rooftop unit. So we're going to show that a little bit here. Here's some other versions of what we've already talked about. You could have a very small window air conditioner, and think of that as a very small packaged unit, correct? Right? Because it's all in one thing. There's no extra furnace anywhere. This guy right here needs a blower and a cooling section somewhere else in the home. There we got a large air conditioner, which looks like to me this is only, I don't know what this is, to be honest, that picture. Oh, that's a packaged rooftop unit. I'm sorry. I didn't even see what the picture was. Anyway, that's a built-up roof right there. Okay, cool. So we got a packaged unit up on the roof. And then we've got this chiller. And we barely touched chiller a little while ago. Okay. But the point being of this lecture is we're supposed to get into some coordination. So let's get into coordination a little bit. What do we need? Obviously, we need power or electricity for all this stuff. So not only on let's go to the residential one. We're going to need power both to the furnace, and we're going to need power out to the condenser, which may or may not be the same. You might see 220 out here. Might this only get 120? I don't know. But the point being that you have also a thermostat. You have some relay information. So a relay is a way to start a signal. It's a communication signal, and be able to start motors and stuff. Here it's got a transformer because this is low voltage on between the relay here. So basically, think of this relay as a switch saying, hey, time to turn on. And it might be here, it might be somewhere else. But we've got a little transformer we talked about, condensing unit, we got power. What else would we need on this? Let's think through our utilities. Water? No. There's no potable water being supplied unless we had a humidifier in there. So if we had a humidification section in here, we would definitely need water. And in Utah, that's pretty common in a home because it's dry. And the cooling section of your forced air unit is actually dehumidifying the air, so it's making it even drier. And so water, for sure, it's possible on a residential unit to have some water. Now we just said that this is a dehumidifier. So if this is running and it's dehumidifying the air, where is the water going from that cooling section? Well, it's dehumidifying. It's condensing the air's liquid back into water, liquid water. Where is it going? Well, you need a condensation line over to a drain. So we need water, we need sewer, we need power. What else do we need? Well, in this case, if we were talking about a forced air unit, we would need natural gas, and most likely in Utah. This could be electric as well. It could be propane, but we need some heating fuel. So that's almost what utility are we missing? We've got water, sewer, power, and gas. All of them in a typical home, right? So we've got all the coordination that needs to be done for all this. So some of the coordination that needs to be done in front of in front of this furnace is we're going to need to be at, let me read my notes here. The door to the furnace room needs to be big enough to be able to get, by code, needs to be big enough to let the furnace in and out. So you actually have to have a door big enough to be able to move the equipment in and out by code. We need a workspace in front of the furnace that's 30 inches deep and 30 inches wide. So we need some clear space, so we can't just jam this into the corner of a mechanical room without any clear space in front of it. Doesn't mean people like myself don't go put stuff in their mechanical room. But during construction, in order to pass your inspection at the end, we would need the space, right? We need physical space, clear space in front of the forced air unit. Let's talk a little bit about our relay. Do we have, oh, we do have the thermostat here. So we need some coordination here between where are we going to put the thermostat, how are we going to route the low voltage wire, where are we going to land the power at for both of these. Don't we need a disconnect as well? Let's see if I have a slide for that. I don't think I do. I do here. So the disconnect for the condensing unit has to be in sight of the condenser by code. But really this seal tight raceway, need this thing pretty close anyways. This little pad right here has to be, I believe, 3 inches above the grass at a minimum. What else? What other coordination would we need? We need to make sure that the electrician knows this equipment so that he can size the breaker correctly and size the panel, get the right number of breakers, and also the service itself. So that's all information that needs to be done early on. We need to be communicating all this information back to the electrical utility, as well as the gas for the BTUs used for the furnace need to be used in the calculation for the gas line. So there's some coordination that needs to happen early on during the permitting process or utility service agreements, that we need to get information to them so that we can size our utility correctly, both how much power and the gas meter size as well. There has to be a receptacle within 25 feet of here, so that you can plug in some sort of power and work on this thing. Let me think. There's a bunch of stuff on the garage that I'm going to get into here in a second. Okay, there's another concept I wanted to share before we moved on to look at some drawings. There's a bunch of control stuff inside the forced air unit, the cooling coil, and probably the compressor condenser. Now, I'm not an expert in all that. I mean, this is showing the inside of a condensing unit, so there's the little compressor motor back there. So this thing is obviously inside the condensing unit, but I'm not a controls expert. I just know that there are controls, and I know that there are various things that need to be worked on. And so from a control standpoint, to make things work. So when I'm talking about scheduling a little bit here, say we set up, let's go back to the graphic here that had the, this one will work. This one right here. Let's say I was anxious to get this thing turned over to the client, this home. And what things, let's not even say that. Let's say we're roughing in. What are we going to do for physical space around this unit here? Well, if you have a floor plan on a typical residential, non-detailed residential drawing, and there's some things like how much space you actually physically need for this forced air unit, as well as the cooling section. What if you have a humidity section in there? That mechanical room itself, it needs some coordination. It needs to be well planned. And so if we're in the framing stages of a project and you're just handing the drawings over to the framer to frame, that's not his job to go contact all these people. Typically, I mean, they would never do that. If you had a really good contract, it might say that they're supposed to do that, but I've never seen a framer go contact a mechanical contractor and say, how big is your furnace? Typically up to the general contractor to try and make that coordination happen. Not saying that they shouldn't by contract if they're really good, but the point being, there's physical space that needs to be coordinated. And we need to make sure that we are coordinating these a path for the control wires, the power, the thermostat wiring. Make sure we have this path all laid out. What else are we missing in here, this path? Well, we need gas. We need a drain nearby. All those are rough activities that we need to be coordinating and scheduling and making sure they happen, as well as refrigerant lines. That's one of the things that I want to talk a little bit more about when we look at the multifamily drawings here in a second. But the refrigerant lines are something that has to be coordinated as well. The refrigerant lines between the condensing unit and the cooling section of the forced air unit. So there's a lot to coordinate there. There's every utility in the home that goes to this stuff, and it's the most dynamic system in the home, really. So it should require quite a bit of coordination. And what I've seen in the past is no coordination. Even I've been guilty of it, where I assume, okay, hey, assume the mechanical room is big enough. I assume we got the right dimensions on there. Well, and we end up putting something pretty big in there, or oversized, or something that's got a weird configuration to it, and all of a sudden we were not having the right amount of space. So paying attention to this physical space in the mechanical room and all the lines going to and from, it can be a big deal. Let's go look at some basic coordination of the forced air unit that we had just a second ago. All right, you should have seen this drawing in an assignment to label the direction of airflow. So let's just try and understand what this is. F4 is referring to the furnace. But maybe I'm even jumping in too far. What is 1 and 2? They're two views of the same of a similar space. This is the crawl space, and that's the main floor. And here's it's just a little addition to an area. So it might seem really small, but it is, because it's just an extra wing to a part of a custom home. So what direction is the air going on a furnace? Is the return air supplying air? Obviously not. I just barely already used it. Returning back to the furnace. So in the direction my mouse is going now. Furnace does the heating of the air. Air is going this way, out that one, out that one. So back to the furnace. Air is going this way, splits right here and goes this way and out that. Over here it split, went this way. Okay, cool. You see the supply air and the return air, RA, SA. Notice also that the return air, it only has one size, 16 by 10. So it's 16 inches wide, 10 inches tall, and it doesn't ever change size. Pretty good indicator that that is not a supply air, meaning that is a return air. A lot of times they never change size. Sometimes they do if they're picking up, if it's a completely ducted return air system. But check this out. So we have 14 by 10 inch section of duct right there. So 14 inches wide, 10 inches tall. We come over here and the ductwork has gone down to 14 by 6 inches tall. And then by the time it hits this ductwork, it's now 12 inches wide, 4 inches tall. Why? Why did it keep going down in size? Well, it lost volume of air. It didn't need to be that big anymore, right? So the air comes this way, and because it was so large here, some of the air is going this way and some of the air is going that way, and they want to reduce the size so that they can of the ductwork so they don't lose the speed in the air. So the air, and it's wasteful too. So what's this little line right here? That's referring to a damper. Oh. I can do this when I can talk. There's no one in front of me. Like, I'm just talking to myself. I hope this is okay. I feel for everybody. I'm really proud of everybody that's still in school. Just had those thoughts lately that, hey, keep going, keep working hard. I know these are late classes, having to do some of this online. I hope this helps. Uh, it'd be tremendously valuable to me in my career had I had somebody to explain a lot of this to me early on. So the ductwork is changing 14 by 6. Note that was 14 by 10. This section's 14 by 6. And it's getting to branches over here that go down to 12 by 4. So and then the 12 by 4 is going up and up. So if I was to label this real quick, I was go like this, that way, that way, that way. Okay, and then that might be the end of it. But the reality is a lot of folks miss these right here. Outside air intake, crawl space ventilation, install bird screen and insect screen opening, motorized damper, interlock with exhaust fan operation. Well, what are they? Look at this little thing right here, that little dashed line. That's saying that right there, the humidistat, it is monitoring the humidity in the crawl space, and that's an exhaust fan, so that's going that way. Exhaust, and then the outside air is going this way. Well, why would we need that? Well, you just do. I don't know. We already covered what outside air and exhaust air does. But obviously you need some combustion air going to this furnace. So you need this to definitely work. But the humidity in the space, they don't want the humidity to get into the insulation in this. So they're going to remove the humidity as well. Okay, now if we went over here, what direction is the air coming out? Well, it's coming out. Lots of different directions on this let's call it diffuser register. So it's going like this, and all the air is coming back into this thing. How do I know? It's a grill, and it is in the same space as this return, so I know that this is negative. All the air is pulling into here. This supply duct, do you guys see that this and this are the same? Meaning, like, okay, let's go over communicate. This duct is directly above, excuse me, this is the register that sits in the duct right here. This is the main floor. That's the crawl space. So that's the register for that end of that duct run. Here's the register for the end of this duct run. Here's the floor grill for that return air, right? And then that duct is this, this diffuser is associated with that. Hopefully you got that. Lots of folks didn't actually catch that was going. And I saw some of them show like the correct airflow on one of these, but then got it backwards on this. So you got to pay attention. Like airflow is coming out of these registers and into this grill. Okay. And I probably should have done something more like this over there on those, because it's kind of like being spread out everywhere, but that was the point. So what about this thing right here? They've got the 7-day programmable thermostat manufactured by Nest. That is definitely part of the system, right? It's telling this when to turn on and off. What set point are they trying to get to with this air? So that's part of the system. That's coordination that needs to happen. So let's just figure out a little bit of coordination that needs to be done here. This is a crawl space, so it's not a full basement. But look at what what information we do have. We have a foundation. Obviously, there's sequence that needs to be done. Could we install this duct? Let's just say we do the foundation, right? Crawl spaces a lot of times are just gravel, so that's something we need to get in there first. We need to get the gravel into this space. Now, it's not showing anything like radon gas or anything like that, but it probably is in the drawing somewhere showing that. So that would have to be installed in the gravel if that's part of how we're doing it. Or maybe we're just venting the, maybe this humidistat, maybe we've got something else. I don't remember, but it doesn't matter. It's not shown right now. But what we do care about is that this has to be installed after the floor framing here, right? Because this isn't going to sit on the ground. This ductwork is going to hug the bottom side of the joist. All this ductwork, I don't remember what the dimension off the ground is. Let me check my notes. Any suspended equipment is supposed to be like 6 inches above grade. We need a light down there according to my code check notes. So we'd need a light down here for sure. But think about what we said before when we said like working highest to lowest. So if we were to work in this space, where's our access point? I don't even know. I don't even know how to get into this space right now off this set of drawings. So one, we need access to it. And you need to be able to get a door in here that's big enough to be able to get this out, this furnace out. So that's all coordination that we need to do. We need to make sure that we're at least 6 inches off the ground and that tradesmen can get back into this location to be able to wire this up, wire that up for sure, and be able to access these dampers. Damper, 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 to be able to access that stuff. Or we're not controlling the volume of air, right? There's some electrician needs to get back in here. We need the mechanical contractor to run the gas to it. And so are those going to be done after this is done? After this is hung? Well, I wouldn't. I would rough in the electrical and I would rough in the gas. And we need a condensate line because this is probably got a cooling section in it, even though it's not showing it. And we've got somewhere we've got a condensing unit somewhere that we need to kind of coordinate. So there's a bunch of rough activities that we need to figure out: the refrigerant, the natural gas. What if there's a humidity section? It doesn't say there is one, but this is a little addition to a home, so I wouldn't be surprised if this set of drawings just doesn't even talk about that kind of stuff, and the client's like, yes, I want that, of course I want that. Then we got to go figure that out as the general contractor and coordinate it, right? Now the framing section, this grill right here, what is it? It's a 24 by 10. That should fit between two joists, right? And you would think that the joists are running this direction, right? And if they're running this direction, then we should be able to figure out a way to get a 12 by 4 and another 12 by 4 duct through that space. But sometimes I've seen them be different sizes, and you have to like get and notice that they're trying to get this to line up really nicely on the inside. I mean, this is something that they do care about. Why did they go to the problem of drafting this in the first place? Well, there's a custom home, and they don't want this diffuser over here and this one off center. They actually want it lined up nice and even. So that what if the framing down below we have 16 inch center TJIs or something like that, but that means you're down to like 14 something. So what if there's a TJI sitting right in the middle of this? Well, then that's not good coordination, because we need to head that off, or we need to do something else to be able to get the TGI to give space for this. So there's some framing coordination that possibly could happen right here. Why do they want the floor grill underneath the bed? Well, to hide it so that no one sees it. But what if there's framing right here? Like kind of the point being, there's a little bit of framing coordination. There's a little bit of sequence issues that we need to pay attention to. Would we want to get this all roughed in before we went and put this ductwork in here? Are we gonna get the roof on before we put the ductwork in? I don't know. Are we gonna get the floor completely done before we get this ductwork in? Are we gonna let people have to do it on their hands and knees and get this all done, or are we gonna let the floor framing happen and then rough and do an inspection and then put this ductwork in? Maybe there's just not a lot of room down there, and that's the best way to do it, and then we cover it with the floor sheeting. Not saying that's how you have to do it. Maybe we can get a door in here and figure out how to get people in and out, and the materials in to be able to work in that. But look at that. That's a pretty long section of duct, 14 by 6. My point being, there's some coordination that needs to be done. I'm maybe over communicating a little bit here, right? Making this as a bigger deal than it is. And this is not a big deal. This is a little area, but the little touches, like I'm saying, matter. Like the location of this, that's right in front of a window. And there's a custom home, and that's the kind of stuff that people pay attention to on this custom home, or else they wouldn't have drawn it like this. They wouldn't have spent the time to show exactly where these went. We've got a little bit of water here that we got to pay attention to. Is that being fed from down below? Well, because this is an outside wall, I'll guarantee that right there is not in the outside wall, that it's down below right here. And it's not a big deal. A little bit of water, drain, not a big deal, but a little bit of coordination of space, sequencing of the trades, and it would all work out just fine. Okay, so we got something small, and I'm hoping that even with something small, you realize, hey, there's a little bit of coordination to be done. Let's look at our 5-plex. I show this 5-plex in the lectures a lot, I think. So we've got level 3. Let's go to level 1. Level 1. Okay, I want you to notice a few things. We got a furnace and a water heater right here. Furnace, water heater, furnace, water heater, furnace, water heater. It's all in the garage. So it has to be elevated off the floor. And what is that? The ignition source has to be 18 inches above the floor. So maybe it can't, but I normally see them elevated a little bit more. Maybe my notes are off on that. Because just the ignition source has to be 18 inches off the floor. But a lot of times I see the entire mechanical platform raised in the garage. And the appliance has to be protected from impact, so it can't just be sitting there without any protection, ready to get run into. So that's sort of like they have to frame this in or something like that. So what would we need? Obviously we needed the clear space in front of this. Do we have the clear space? I don't know. Maybe if we put a door right here, or something else. Maybe we leave this open. I don't know. I got to think about that. Oh, do you ever see that left open? No. Normally I see like a door that you just open right in front of this thing, or 2 doors, and it opens right up and you have all the space you need in front of it. Alright, the point being, we've got a furnace and a water heater. Over here is our meters, and on the front of the house is the gas meter, front of the complex. So again, the same kind of thing. We need a physical space. But where is the ductwork going to come from the furnace on this? Well, obviously we need to get into this space and heat this space. And I'm assuming the furnace here is going to heat and cool this space above here, the second floor. So we need to coordinate. And look at that. There's no information on any of these drawings, I guarantee you, about drops for ductwork. So the ceiling has to be dropped in order to be able to get ductwork in each of these locations. So let's go look at I don't have it open, but I know on the structural drawings there's a beam right here. So if we're planning the furnace ductwork to be hidden in the floor, there's a beam in the floor right here as well. So there's some coordination challenge right there. Maybe we're not going to be able to get to this over here, this room over here to this side to feed any kind of they kind of do show like the register locations. Register. Did I just say register? Yeah, register. Keep getting register, grill, and diffuser in my head. All right, register locations, showing them. But we got to get ductwork to it. How are we going to get ductwork to it? Maybe this is in, yeah, I mean, this maybe we're going to have to feed this one from the next floor up. So where's the next furnace going to be located? Is this the furnace closet for the next one? Do we come up here and create duct run to this and to that? This is all stuff that on, look at that, there's a supply air register here as well. So how are we feeding this with ductwork is the question, right? So if there's a beam in the floor right here and the furnace down below is right here, we're not going to be able to get through to get to that one. And maybe we do it in the next floor up. Imagine it being in the floor of, or the ceiling, the roof, the ceiling space of the second floor. So if this is another furnace, maybe this furnace comes over and gets it, and that would make sense. So we've got no furnace here on the third floor. So maybe that's what we do, is have all the, maybe that second floor is where we tell our mechanical contractor, please design us a system where the mechanical on the second floor is big enough to feed. Let's see, what would we need it to do? For sure we need it to do this one, but to me it seems like a bad deal because we want it to be on the same thermostat, so we couldn't do that. So we need this whole floor to be on the same thermostat, and I'm wondering if we could do that here with this, because I just don't see how we're going to get to that, because there's a big beam in the way right here. Yeah, I don't know how we're going to do it yet. So the point being, there's some coordination to be done. And they've got, look at that little grill. What's RA? What's RA? Return air. There's the register as well. Register. Could we get through all this? I'm pretty sure we can. The only one I don't think we can get to with this furnace, if this is what we want to do, is the next floor here. Could we get to all these with that other furnace, or would we have to use this furnace and use its ceiling space to create some drops in the ceiling to be able to get that drop down from the ceiling and not from blowing up from the floor? And does this furnace itself feed all this? Yep, for sure, because there's not another furnace even showing a location for a furnace on this one, on this floor. So what I'm seeing from the set of drawings as I think through it is that there's a bunch of ceiling drops on this second floor ceiling that have to be done in order to get, and we need to make sure that this furnace is planned large enough to get this, and the one the next floor up above, and the other furnace downstairs, it's just going to feed that little area. Or we're going to figure out something else we're going to do, and but that's all coordination that needs to be done. That's the point. We need to coordinate it. All right, so let's now go to the refrigerant. Now, on these apartments like this, where do they put the condensing units? Where's my condensing unit would be? I've seen it where they just stack a whole bunch of them, a couple of them here and a couple of them over here. I've seen it where the condensing unit's on the porch. It's not ideal. That doesn't seem like a great place for it, but I've seen it there. So where are we going to put the condensing unit? How are we going to get refrigerant to these? One of the things that I think is when you get into really big multifamily, the natural gas that needs to get to all these locations, the power that needs to get to all of them from this one's got individual natural gas at each little unit. But can you imagine what kind of chase you would need if you had like an apartment complex, and how big of a chase you'd need for all the service for their panels coming from the main meter panel on the outside, or from the series of condensing units on the roof, or the series of condensing units on the ground floor, or a series of natural gas meters that need to be on the side of the building somewhere. That's a big deal. How to route all that ductwork. All the we just covered ductwork, but how to route all the electrical main service, the gas main service, how to route the refrigerant. And one of the challenges with refrigerant is highly recommend, if you're going to do something like that, picking one wall right here and not letting it like get spaced out everywhere throughout here. Maybe get it to go up in one area so you can really protect just this one cavity from here to here, and everybody knows. Paint it on the ground, have it talk about it in the sub coordination meeting. This is where all the refrigerant lines are. We cannot be running screws from drywall. We cannot be running nails from base into these locations. Protect this area and really pay attention when we're doing these. And it would be a bad day if you had like a bunch of refrigerant lines spread everywhere and is getting nails or screws into them. Be no fun. And to say like, hey, we put the plates over at the plate, but that doesn't stop anybody from shooting a base or a trim nail right into your refrigerant line. Or sometimes, like I said in the past, like people will use this back of closet right here, and this back of closet makes a great place for a chase sometimes. And then the person putting in the closet mechanism sits there and shoots this closet system together and punctures a bunch of, or drills into it or whatever. Man, that's seen that a lot. Got to really pay attention to and communicate where the refrigerant lines are going, and the gas and the electrical. All right, I'm looking at my notes to see if let's see. Okay, I think I'm good. Let's go to the next one. Get more complicated. This is a dentist's office, and we've got the main mechanical plan here. So let's just kind of trace out what's going on. On the roof, there's a rooftop unit number 2. And on the roof over here, there's a rooftop unit number 1. What's this T? What do you think that T is right there? Let's go find it. Let's really figure out what that is. Oh, it's a thermostat. You probably already knew that. I was just trying to make sure that we're showing how to find that information. What are these little things right here? We can go back to it. Parallel blade damper, is that what we were looking at? Pose blade damper? Or were they turning vanes that aren't labeled? Yeah, they're just turning vanes. They're not labeled. Okay, so what are we seeing right here? We are seeing a rooftop unit. Do you see this little dashed? Let me actually draw over the top of it. That right there. I'm going to move the line out of the way, offset a little bit. Do you see that? It's a packaged rooftop unit. Heating, cooling, probably. So inside of it is a lot. It's the same thing we were looking at in PowerPoint, where it's an entire unit that has a heating section, a cooling section, the blower, all in one place. Right? It doesn't have the separate forced air unit from the condensing unit, like outside, like a residential. This thing's sitting up on the roof and it's got heating and cooling to it. So what do we need by way of coordination there? Well, if we went to the steel drawings, let's see if we can find it. Roof framing. Roof framing plan. Well, that is right there, the RTU, and they're saying double joist, double joist, double joist, and they're picking up. We'd have to go read through like whatever else he's got here because I don't know what this is. Maybe that's just the outline. Yeah, but he's got double joists in through here. Double joists over here. Okay, that's helpful to know. So we've got some framing to deal with. But take a look at this right here. We've got a 28 and a number 27 coming out of the rooftop. So 27 is on this side, 28 is down here. 27 to 28. Transition from supply air opening on rooftop unit 2 above to a 16 by 16 by 1 inch AL supply air duct and drop down to serve this level. Okay, so 27 is the opening for the supply air duct, and they got the size here and insulation requirements. So, and then we've got a 24 by 14 return air duct on number 28 going up through the roof. What size did he say that they were? 27 is 16 by 16. 28 is 24 by 14. So we got a 24 by 14 hole in the roof right here. We got a 16 by 16 hole in the roof right there. Let's go back to look at the roof structure and see if we actually have any kind of opening there. Well, maybe that's something we need to make sure that the framer has for sure, because right here it looks like he's got double joist, double joist, double joist, but then it looks like to me like the spacing still carried through, and maybe this guy's actually in the way. I think we better be paying attention a little bit up on the roof for that one, because on this one, double, 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 and they're spaced out. What's the spacing of that? That is 24 inches center on that. For these, what are they? 9.5. Does that say LPI? All of them have like the L cut off. Alright, anyways, the point being we need to coordinate that roof opening. So we've got duct coming down here, duct coming up here. So what is this right here, right? That is that guy right there, 21. Do you see the RA? Return air. This has got to be the return side of the makeup air unit. Sorry, not the makeup air unit, the rooftop unit. So this is the return side. The air is coming back this way. Why isn't this all branched out everywhere? It looks like this is touching right here, but they're not actually touching. It looks like this right here and that. Why are they connected? They're not connected. They're just drawn very close to each other. And this whole section is pulling air from everywhere over here. And hopefully you remember the idea of a plenum. But look at their, let's go look at their roof, their reflected ceiling plan. Main ceiling plan, there we go. Diffuser, diffuser, diffuser. Those are like registers, but in the ceiling. And I don't see any return air grills, but they got to be here somewhere. Or they're just allowing the, no, got to be here somewhere. They're just not showing it. But know that that's all reflected ceiling or acoustical ceiling tile on these little grids everywhere. And so the whole space above the walls is a plenum, meaning the air just gets into the ceiling space and makes its way back to it gets back, so the air would come out here, right? And into the space, condition the space, and somehow it's going to get into, this might be it right here. Here's your return airs, 20. See any other return airs? Got a bunch of return air grills right here. I'm not seeing the other ones right off the top of my head where they are, but somewhere it's going to let the air get into the space above the acoustical ceiling and get pulled back to this negative pressure duct right here and back into the rooftop unit to be most of it to be returned back into conditioned air again and come back to here. So where's this going? This is a lot of lines. It can be very hard to understand and realize what's going on. But if you really pay attention, like zoom in, okay, that's coming down. Here's my rooftop unit that's above it. And so this is coming down, and then the air is going this way. Oh, hey, now we're branching over and feeding this space. And over here, okay, we branch over off that trunk and feed the space with air. Oh, it necked down. Why did it neck down? Because it doesn't need that much volume of air anymore, because it's losing air out of it right here. Not losing air, but it's supplying the air right there in this 8-inch round. 14 by 10 now. Turning vanes. Now we're getting into, we have another diffuser. And going out another diffuser. Why is this arrow pointing back this way? He's just used, whoever it is, that engineer, just used this graphic. And this is not meant to show the direction of air back in the duct. It's actually below the duct, below the ceiling. The duct is above the ceiling, and this is below the ceiling. HDs, well, it's a damper. Let's go see what the H stands for. Oh, hey, there's turning vanes, look. Hand damper. Alright, I didn't know what the H was. Just a manually turned damper. Number 1. What does number 1 say about all these? Number 1, number 3. I'll bet they're talking about the volume of air. Yes, 200 CFM, 8-inch, a neck supplier diffuser. Number 3, 280 CFM. So what's this hand damper doing? Well, they turned the damper. Let's see if we can find a round damper online real quick. There you go. That's 16-inch. It's the wrong size, but that'll work. That's what we're talking about. They're turning this and setting this to be able to block or open a certain amount of air so that you can only allow, I forget what it was, 200 CFM, 200 CFM, 280 CFM. Was that what the 3 was? 280. Oh, 200, yeah. So they're saying that this doctor treatment room is getting 200 CFM. This doctor treatment room is getting 200 CFM. This private doctor treatment, 280 CFM. Okay, we're getting 200, 200, 200, so all that. So the diffusers, another one right here, mechanical room. All right, what are we? I'm hoping you saw that. Like, I'm hoping you saw, okay, that air's coming down from the rooftop unit. And that's all supply duct. Let's see if we can follow this one. So this one, it's even labeled for us. Let's see if I can find it. I'm thinking this is our rooftop unit. It might be some weird shape like that, actually. Have a little, some sort of section on it. I'm not sure, because it's got that dashed line going over, but it's also cutting over here. So it doesn't really matter to any of this point, but we need to get this equipment, whatever rooftop unit it is, pull their product data, and go give it to the framer to show them exactly, get the mechanical and the contractor and the framer to work together, because look at that dang opening. That thing is good size for that return air. 36 inches. So back to that roof. Do you remember that roof plan? Roof framing plan. There's no way there's 36 inches between those. So for sure we cannot just frame this. We've got a rooftop unit up right here that has a 36-inch wide opening in it for all right, now we've got to figure out, so what is this? This is the supply side, that's the return side. Should we follow the return kind of back? Notice that on this one, they've got it ducted. They've got return air ducted here. Look, they've got even like an arrow showing where the air is coming out or coming in. Air in, air in, hand damper, right? 25, that's got to be one as well, because I believe that's coming over here as well. Look at that, 25. Yeah, 350 CFM neck return air grill. 25 is a return air grill. It can be complicated looking at this stuff. I know, I'm sorry if I'm spending too much time on it, but I want you to get, no one ever spent any time with me to be able to say, hey, this is how you read these drawings. And this isn't a terribly complicated set, so this can get really complicated, but that's a return air. return air. Okay, then we come into this big duct right here, and it's going up into the rooftop unit right here. Well, there's also return air coming from this side. Return air. Don't pay attention to these things because that can be like confusing. That dashed is just showing that that's below it. We got this 20 by 14 return air. We got a return air coming in here, here, back to there. This is also return air duct. Look, we've got a return air duct right here, into there. We've got this return air right here, into there. Got this return air into here as well. And if I was like early in my career, it'd be like, why are these touching? No, you really got to pay attention to what this is. Supply air, that's a return air, and so it can be hard to figure that out. But really, if you get the concept, this is a duct right here, and it's trying to pull air back to the rooftop unit. It's a no-brainer that duct is not connected here at all, even though the lines are touching. And these little segments are just showing like allowing the air to make the bend. This is straight section, 90 section, straight section, kind of like this section is the T into this return air trunk line. This one right here is just saying it's coming from above, I believe. But I have to go look at the drawing notes. So we've got this return, and we've got a big return line right there. So 14. So that was a big ducted return line that's not using the plenum space. Why? No idea. I don't know why. I don't know why they're not using the plenum space over here, and they are using the plenum space here on this side for this return. Couldn't tell you. Don't know. Actually, I think I do know, because somewhere in here there's going to be a fire rated wall that's going to go up to the roof. Should we see if I'm right? So we're looking for, let's see. Yeah. Somewhere in there we got something going all the way up. I don't know. I could be wrong. Some occupancy separation maybe. I don't know. I have to look closely at it. But it's a good set of drawings because it's showing you both ways. Showing you ducted return. Right? So we got this ducted return where this might be the farthest away. Ducted return back to the rooftop unit. Got some more ducted return lines back to the rooftop unit. Comes back to the rooftop unit. Some of it's going to be exhausted, some of it's not. And it's going to get turned back into supply air. We're going to be conditioned again, come down from the rooftop unit here. And now this is all supply. I know, I see it. This is super confusing. Michael, why the heck do we have this line right here? But you got to think, oh, that's the return air line over the top of this. And you see the little dash line? The engineer's trying to give you a heads up that this supply duct is lower than this return duct right here. Supply with a little branch. So 16 by 8 supply, another branch. Got these little 8-inch rounds and going to this really long, thin number 10. What are they going to call it? Are they going to call it a diffuser? They do. Supplier diffusers, a 2-inch, 12 foot by 2 slot supply air diffuser. Got that supply air diffuser right there. Getting fed by 2 locations. Got that. Do you see that trunk going right through here? Okay. Let's just finish it off. We got some more right here. We've got that guy right there. That's a diffuser. What are these little things? Well, CEF. I know EF is an exhaust fan. I don't know what CEF is. So let's go back to the mechanical schedule. CEF, I don't know. Oh, ceiling exhaust fan. All right, whatever. They always say something else, but EF is always exhaust fan. We've got some exhaust fans there, but they're not really doing anything. They're just pulling air right out of the space and into the roof. Out the roof or out the side of the roof, or out the side of the building. This is kind of cool. Look at this little thing. That's an air transfer device, 13. Air transfer. Return air grill on wall. Well, it's air transfer in my mind. It's just moving air. It's just a hole in the wall. That's two grills on the side of the wall, on each side of the wall, that's allowing air to go through the wall to get into this space, because they're not trying to do anything. They're not conditioning the space. They're just letting the air from here get into here. Okay, what utilities do we need for this rooftop unit that is on the roof, graphically shown right there? So it's a rooftop unit and it's packaged, so you're not getting much by me as telling you like exactly what a rooftop unit is, but we looked at it in the PowerPoint where it has a furnace side and a cooling side, so it's all together in one thing up on the roof, and it's got the cooling section, so in this cooling section it's going to have the evaporator coil, it's going to have the refrigerant compressor and the condensing unit, right? All on one side, and then it's got a blower, and it's got the probably furnace, gas-powered furnace on the other side. So, or gas. I said powered, gas-fired furnace on the other side. So those are some utilities we need. We need gas. We need power. We don't have like a condenser somewhere else, so we don't have to run refrigerant lines to it because it's all in one, right? So we don't need the condensing refrigerant lines. It's all inside that. We have to cord. What other utilities do we need? To make it run, power, natural gas to make it run, and we need the low voltage thermostat stuff. So where's the, oh, here's the T-stat right here, the thermostat. So we need the control system, but it's pretty simple as far as what we need. Why don't we need, it has a cooling section and an evaporator section, so why don't we need a drain, a condensation drain? Well, it's up on the roof and there's already roof drains up there, so you can spill that condensate right on the roof, and the roof is designed to take water, so it can go right down the roof drain. It's just it's not bad water or anything like that. It's just air that's been got condensate in it, or vapor that's been cooled off and turned into condensate, liquid water condensate. So we don't need the sewer because it's not down in the basement like the residential one. And we don't need water to this because they don't have a humidification section, but if they did, we would need water to it. But I'm pretty sure most of these do not have a humidity section in it. And so that's pretty easy on the utilities there. The main piece that we needed to coordinate was the roof structure, because on this one over here, I mean, we saw for sure that there's joists right through here, not roof joists, but roof. I can't remember the term of it now. Getting tired. Yeah, they call them roof joists, double joists. All right, well, whatever. So we got the roof structure to worry about. Something else we need to coordinate is something called a curb. Let's go look at what that is right there up on. So we're going to try and Google it.
Okay, but first you'll have to unlock your device.
All right, my phone thinks I need to do it too. This is a good, that's a good photo right there. Look at that. Perfect. Look at that. What is a roof curb? Design components. See that right there, that thing, and it has the supply and the return, or one of, I don't know which one's which, obviously. But there's a little thing that comes off the roof that it sits on. So there's another good version of it, roof curb, right there. So on ours, we had on one side of the rooftop unit is going to be the condenser, the compressor, the evaporator coil, the heating, the blower, and then the heating section. And over here we have the duct supply and returns. So that's a nice example of a roof curb. There's a picture of one. We've got the roof curb to worry about. So notice how they have this little thing right there. Why do they have that? It's called a cricket. And so they're trying to make it so the water doesn't pond on that. Let's go look at the roof on our drawings that we need to pay attention to. So let's go look at our roof. Roof plan, here we go. So here's our RTU, our rooftop unit. And notice that it is on, one side of it is actually on the ridge line of it sloping from here to there, here to there, here to there. So there isn't an issue with this one blocking water because it's at the top. It's at the high point of the roof here. This rooftop unit, it's in the way of water going to the roof drain. And so think of snow and stuff like that, slush, snow turning to slush, and then back to freezing again. And imagine that sort of sliding along right here. Well, if we don't do anything about, do you see how they have this tapered cricket insulation right here? The architect already figured it out. But sometimes they don't, and they miss it, and it's up to the general contractor to coordinate that. But what do we need to pay attention to is the roof curb height. So if we have a pretty big tapered insulation cricket that's built out so that the water will flow this way and flow that way, if that's built out and that goes up pretty high, some of them can be pretty big, and it would be a bad day if we didn't have enough room from the top of the roof to the openings of the rooftop unit trying to get the cricket. Anyway, cricket is something to pay attention to. I have sequence stuff here. So we have picture of, this is not the right situation because I think that's all wood framing, but I know it's all wood framing, right? That whole structure, but we need to plan high to low with the ductwork and all the other parts that are in the ceiling space. So what's highest? Almost always the sprinkler pipe is almost always high. And so we need to be paying attention to that. See, maybe this goes in first. Maybe the ductwork goes in first. Are we going to frame first? If we're going to frame first, then we're going to expect somebody to be cutting out holes. Let's go look at that. Oh, maybe not, because not all the walls go up to the roof, because there's a big plenum space. But maybe they go up, but they don't sheet them past the ceiling space. Maybe they don't put drywall on them. So anyways, framing sequence, above ceiling is usually highest to lowest, is the roof is the sequence of construction. So just like my picture there, we're going to go maybe the highest thing up there is the sprinklers, and then maybe the duct. But I did want to talk about, I had a good, wasn't this one? There's another one. Okay. Check this out. So we got a fire rated assembly here, and we got a fire smoke damper. And so that's something else to try and coordinate is these, if you have ductwork going through a fire rated wall, a lot of times they have something called a fire smoke damper, which will close and not allow air to continue to pass through this fire rated assembly, assuming that might be receiving smoke or something in the duct, right? Or you don't want to continue to supply fresh oxygen to this space over here through the ductwork. If it was on fire, we want it to run out of oxygen. So this fire rated assembly, the smoke detectors and stuff, you got to pay attention. I mean, the fire smoke dampers, sometimes those are monitored, sometimes they're not. Sometimes you have to have access to them, sometimes you don't. Kind of getting into like coordinating space again, coordinating openings in framing, making sure the framing contractor's talking to the ductwork contractor, making sure they're coordinating in the sub meetings, and we're working top down. All right, well, I feel like it's been a good getting through a set of drawings, getting through the idea of a rooftop unit. I hope that made sense. I'm hoping we started out simple. We got into the fiveplex where it's simple, but again, it gets complicated because there's not enough information, and that's by design. That's not that they're at fault or anything like that. It's just that this method of construction is going to lend to something else. That the mechanical contractor is probably going to get hired to do the design of the mechanical system fully, and all we make sure is that we're coordinating how we're going to feed all these, and making sure that the mechanical contractor that gets hired is paying attention to things like the beam that's right here for the structure, and we're paying attention to that kind of stuff. We got into the small commercial building. Let's see if we can find a picture of this thing. All right, so we got a small little commercial building, and kind of the ductwork throughout here that we got to pay attention to a little bit. And what would we need to? And this is all wood framing, so I don't know how people feel, but for me, wood framing is maybe a little easier to cut holes in for the ductwork guy, for the tinner to go through. I still think that's messy. I'd still rather us go coordinate a bit. But hopefully got something from this lecture. We'll see you on the next one. Thanks, everybody.